Hello, it is Saturday, December 3rd, 2011 at 3:45 p.m. Central Standard Time. I want to show you a few things that are happening in Florida, something I'm observing. Actually, I want to start over here. This is Jacksonville, Florida, and they've installed the new Doppler that's got the constant beam. And this is, let me see, Melbourne, Florida right here. Key West is down here. And we've got New Orleans up in here. And what I noticed is that in Jacksonville we've got these little beams going back and forth, and that they seem to be pointed at Melbourne, which is highly excited. You can see the little stuff coming out of the ends there. And so, let's see. Oh, here we go. I went to the NEXRAD Doppler, and I wanted to notice these beams. We got this one's constantly on, and it just seems to be sitting there doing nothing. Let me zoom in. Yeah, not too far. And then this one's got a constant beam, but there seems to be a beam behind it that's pulsing. And then both of them seem to be pulsing. And this is the same thing, both of them being pulsing. Now the reason I'm talking about pulsing is, let's see, right here. I did a video called Harp Ring over Minot, North Dakota 1 back in August. And this very kind person replied and said something constructive, which is really nice. Most people critique and they don't give you anything, they just complain. But Carrie Fox said, "This is an 88D NEXRAD Doppler conversion ring. It is caused by the 88D switching PPS radiation. Call the Doppler site and you will find they were testing their new dual-phase radar. All U.S. radar is undergoing an major upgrade, and this effect is part of bugs in the technology. Thanks, Carrie." Well, I didn't know what a PPS radiation was, nor did I know what dual-phase radar was, so I went and checked it out. And this is what I came up with for PPS radiation. This is called phase distortion correction for see-through-the-wall imaging radar. And I'm not sure how this would apply to the weather, but I did find it interesting. See-through-the-wall STTW applications have become of high importance to law enforcement, homeland security, and defense needs. It is this work surface penetrating radar is simulated using basic physical principles of radar propagation. Wave number migration is employed to form 2D images of objects found behind a wall. It is shown that this technique cannot properly image with the wall present because of an unknown phase delay experienced by the electromagnetic waves as they pass through the wall. Two approaches are taken to estimate this phase by looking at the direct backscatter signal from the wall. The first is a dual phase approach, which uses a non-parametric technique to find the phase at every frequency. The second method is dual frequency approach. The two frequencies are close enough together that the reflection coefficients are approximately equal. This approximation allows for more observations than unknown parameters. The surface reflection coefficient, backwall coefficient, and phase are simultaneously determined using an iterative nonlinear Newton-Raphson successive approximation, logarithm. Anyway, comparisons are performed for a simple scenario of 3-point scatters with and without phase correction. So that sounds to me like you're just phasing it to see around something, and that may be what they're doing with the Doppler. But the other things it can do is somewhat disconcerting if indeed they can use the same thing to do other things. And then I also found, looking for the PPS radiation, I found, well, the last one was dual phase. This is PPS radiation. I found this integrated sensors. I didn't find much on it. So what they're saying is PPS means plasma panel sensors. So I'll read this background. Integrated Sensors is the first company in the world to apply the high-gain, high-performance properties of low-cost PPD TV plasma display panel technology to radiation detection. This has resulted in the invention and development of what is now known as plasma panel sensor, which has been called a revolutionary technology by the U.S. government scientists. Integrated Sensors holds the core intellectual property on the PPS radiation detector technology. The PPS could prove to be a transformational technology for a number of multi-billion-dollar industries, ranging from radiation therapeutics for the treatment of cancer to the detection of nuclear weapons. For example, a recent review from the U.S. Department of Energy stated that the possible applications of the ideas go well beyond the mere use in physics research, extending to homeland security and medical imaging, for example. And you can go through these different talks about the company and the government research and applications and what's good about it. They did have a I didn't read this one. So I'll give you a link so you can go read it, because I want to get back to what's happening here in Florida. What I noticed also is that in line with these beams is the Doppler down in Key West. So I went and looked at a closer image. Let's see. Yeah, see, I get talking and other things. I lose track of where I'm at. Here we go. Let me zoom in. It appears that these beams are coming, this beam comes basically right at this Doppler, and it looks like it's pointing right at this green area. But you can see that there's not really much moving in, but we've got things are moving out of that area, like it's being generated within that area of the radar. I went and looked at the loop. Let's go look at the loop a minute. Oops. Back down here. And you can see what I'm talking about. Let's see how this is such a high. Now it's not quite the other radar's more up this way. And then also we've got a beam going down into Cuba or coming up from Cuba. I'm not sure, but you can see it right here. Let me go slower here. Right here it's pulsing. And then you can see that there's really nothing coming in, but everything's going out. And these are like those little snake clouds that I've been seeing down by Key West. I saw them down by Cuba the other day, and then I did a video on the ones by Key West. I did another video on the ones by Louisiana, because they seem to go up to, let me show you here, back to this one. See, they're coming up here, and now we got them showing up over here too by Louisiana, coming on shore. This whole area we don't have radar coverage for. And let's go look at New Orleans too. You can see them coming ashore. See, there are several little, they kind of grow together into one long string. I would call them string clouds. I think I'm going to settle on snake clouds because they kind of wind around. They're not straight. They're always curved, almost like an S curve. So here's what the visuals look like. Here is the whole Gulf, and I can't really see anything. In fact, here's the Keys down in here. You can see clouds moving in, but you can't really see anything moving out of that area. In this area up here too, with the snake clouds, I can't really see anything different. We've got this coming across to meet it. And it looks like this is moving up in this direction to some degree. Yeah. And then here's another view. I'll give you this loop timing so you can kind of see where we're looking in time-wise. It starts at 3:45 UTC on December 3rd, and it ends at 20:45 UTC on December 23rd. So anyway, there's some food for thought. Um, it looks like signals are being sent out. It's not just reading, which that's how it reads. It sends out signals. But dual phase and PPG. So maybe, or PPS. So maybe someone can enlighten me more on what this PPS is and how it might be used in Doppler. So anyway, God bless you. Have a good afternoon.